Hey guys, Mr. C here. Today we're going to use the physics strategy to solve an example kinematics problem. So by the end of this video, you should be able to learn the physics strategy for solving problems and apply it to a variety of situations. So let's discuss the physics strategy for solving kinematics problems. First, whenever you see a problem, always read through it once just to get an idea what the problem's asking. First of all, is it like a kinematics problem, a Newton's law problem, an optics problem, etc., just to kind of get a feel for it. Once you've done that, reread the problem. This time you want to underline whatever the important physics terms are, such as do they give you an acceleration, a force, a mass, a time, etc. And then next to them, you label them with a letter. So if it was a time, I'd underline and write the letter T. If it was a mass, I'd underline and write the letter M, etc. Step 3, always draw a picture, if possible, of the problem, and try to think about any hidden information given in the problem, such as if it's a ball falling up and down through Earth, you know that gravity is going to be a factor. If they ever say the words from rest, you know it's of initial velocity of 0, and there's lots more that we'll talk about that come up all over the place. Once you've done that, step 4, on your paper, make a list of all the relevant information to the problem. So all the stuff you underlined and put letters next to, now I'll put it all in a nice condensed list. In step 5, once you've made your list of relevant information, you then go to your reference table and seek out an equation which contains all the information you put in your table, as well as, and most importantly, the thing you're trying to solve for. That's the whole point of the problem in the first place. Next, step 6, right next to your table, write the equation down. Always write the equation down, just copy it directly from the reference table. Step 7, directly below the equation, you're going to substitute all the values that you put in with units, so right underneath it so that you can check. Step 8, perform the math to solve for the variable, and then step 9, always have an answer given with units. So let's go ahead and apply this with an example problem. Problem sounds like this. A 3-kilogram mass is thrown vertically upward with an initial speed of 9.8 meters per second. What is the maximum height this object will reach? Neglect air friction. So, reading this problem, it's a ball being thrown up in the air. That rings kinematics, maybe a projectile motion, but something along those lines. So right off the bat, I'm looking on the mechanics part of my reference table and somewhere near the top in that kinematics area of units. Now I go through and start underlining reading again. So a 3-kilogram mass, underline it, that's the letter M, is thrown vertically upward with an initial speed of 9.8 meters per second. Well, initial speed, that is my VI. What is the maximum height this object will reach? So we're solving for a height, which is a measure of a distance, and neglect air friction. So I've now underlined, I've seen some of my things. So we go up to our strategy. What's the next step I'm going to do? Step 3, draw a picture. So now that I've underlined it, draw a picture. So here's the person throwing a ball, goes up in the air. We want to find whatever this height is. What do we know? We know that the initial velocity of the ball is 9.8 meters per second, and we know the ball has a mass of 3 kilograms. Good. Now we go on to step 4 of the process. Make a list of all the relevant information. Oh, sorry. Step 3, draw a picture and think about any hidden info in the problem. Any hidden info in the problem. This is a ball being thrown up in the air on Earth. So a couple of things that scream. First, if it's being thrown up in the air, we know that gravity is going to come into play. So we know the acceleration is going to be gravity, which is negative 9.81 meters per second squared. Finally, there's another piece, and that is the word maximum height. And so one of the big things in physics is when a ball is at its maximum height in the air, it momentarily comes to a stop because it's going up and then it goes back down. So we also know that the velocity is 0 at the top. And if we call the initial velocity when it starts, we're going to end the problem at the top, so we're going to call that the final velocity. So now, next step, we make a list of all of our information. So we know the initial velocity is 9.8 meters per second. We know the final velocity is 0. We know the acceleration of the ball is gravity, negative 9.81 meters per second squared. Oh, sorry, get my table back. We know the mass of the ball is 3 kilograms. And in this problem, we're asked to solve for the height that it obtains. So I just put a question mark there. So now I go to my reference table and I try to seek out an equation which contains these variables and has to solve for a distance. So upon inspection, I arrive at the following equation. I see that I can use VF squared equals VI squared plus 2AD to solve the problem. Because I definitely have my VF, my VI, I have my acceleration I'm trying to solve for my distance. Perfect. So now directly below the equation, I plug in. So below my VF, I put a 0, keep the math operation squared. Below my VI, I put my 9.8 squared plus 2 times gravity, which is negative 9.81, times the distance which I'm trying to solve for. Now, there's one thing you should also be doing, especially Regents Physics, you're going to get penalized for this. Notice how I substituted in, I made a mistake. So whenever you're substituting in, you have to substitute in the units as well with the equation. So I'm going to go through and resubstitute them with the units. It looks like this. 0 meters per second squared equals 9.8 meters per second squared plus 2 gravity, which is negative 9.81 meters per second squared d. There. So that's now the proper way to go about solving the problem. And what's nice is once you've substituted in once, that's all you have to do, at least for Regents Physics. So now I go about solving. Well, we know that 0 squared is 0. When I go ahead and do my 9.8 squared, I get 96.04. And if I do 2 times 9.81, I get 19.62 times the distance. Of course, that's a negative because the gravity is negative. So I go ahead and solve for distance. So I subtract over the 96.04. So I get negative 96.04 equals negative 19.62d. And then solving for the distance, I just simply divide, and I get distance is 4.90 meters. And there's my solution, my maximum height. So there is an example physics problem involving kinematics showing the problem-solving strategy. Hope that helped you guys out. Stay tuned for more.